Okay, so this video is for and about geometric mean. Listen, today is the day to really pay attention, right? Today is also the day you're going to need pencil, paper, and a calculator, so definitely go get pencil, paper, calculator. With geometric mean, it is actually something that is in right triangles, and so that is what our focus is going to be on today. With right triangles, though, there are some concepts and ideas that you already know about right triangles. One of them is Pythagorean Theorem. There's going to be a lot of Pythagorean Theorem involved in what we're going to be doing today. And one of the other things that you're going to need for today's activity is to be able to simplify radicals. And simplifying radicals is something you just haven't done for a really long time. I want to go ahead and do with you, for example, okay, this particular problem up here. So this particular triangle right here. With Pythagorean Theorem, remember it's a squared plus b squared equals c squared. So you would do 8 squared plus y squared equals 12 squared. Okay, but again, with Pythagorean Theorem, and a lot of the Pythagorean Theorem we're going to be doing today, we're going to kind of do a little shorter version of it. And so whenever you are doing Pythagorean Theorem and you have something like this, if you're looking for a leg, you're going to subtract. Okay, so let's go ahead and do an example, or go ahead and do, this particular problem. Okay, so we had on that triangle, we had a 12 and an 8. Okay, and we're trying to find this side right here. Okay, so when you do this, you're going to do 12 squared minus 8 squared and see what you get. Okay, so if I get my calculator that you need today like no other, okay, 144 minus 64 is 80. And here's what's going to change for us a little bit today. Instead of doing the square root of 80 and getting a decimal, we're actually going to simplify this radical. So I know that 80 is divisible by 5, okay? And luckily, it's divisible by 5 with what's called a perfect square. So I'm going to break this down to a 16 and 5. So 80 is going to be the square root of 16 times 5. Okay, and then we know what the square root of 16 is. The square root of 16 is 4. And so the square root of 80 as a simplified radical is going to be 4 times the square root of 5. So I just took that 16 and I did the square root of 16, which is 4, and kind of pulled it out front. All right, now that's all well and good, Miss Hunsker, but what in the world is this geometric mean thing? So I'm going to go ahead and play this video for you. Not quite all of it, just a couple minutes of it, but I want to show you something about the geometric mean.
We begin right triangles with something called the geometric mean. The geometric mean is the altitude of a right triangle. We call it the mean because it is the middle number that gets repeated in the denominator of the first ratio and the numerator of the second ratio of the proportion. What happened is that the altitude drawn on a right triangle to the hypotenuse divides the triangle into two smaller right triangles, and by doing so, the three triangles, the original large one, the one to the right, and the one to the left, are all similar. This means that all their corresponding angles are equal, and corresponding legs are proportional. Let's do some examples. If the altitude of a right triangle is 8, then the geometric mean in the proportion of the other sides is also 8, and controls how large the other sides will be.
Okay, here's where I'm going to pause it because this is the part that is super important for you to know. On the geometric mean, basically, the altitude that comes down is going to split the hypotenuse of the large triangle into two pieces, okay? And so this ratio is going to be the same every time. So you're going to do the side over the altitude, and then the altitude over the other side. So again, that ratio, this ratio right here is the same every single time. The altitude comes in and you do AD over 8 and then 8 over DC or CD, okay? So that is really huge, really super important to know. All right, so what does that mean in terms of your activity and actually doing problems? I'm actually going to do a couple of them with you, but the activity that I gave you is actually Mad Lib style. And so there are some multiple choice possibilities of what your answers can be for question numbers 1 through 10. Once you get done with question number 1, you're going to come in here and you're going to write it down and fill in the blank. But I wanted you to at least see what some of your options could be and make sure that you get the right answer, okay? So let's go do number 1. This is a perfect geometric mean type of problem. It is actually exactly what we just looked at in the video. So let's go do this, okay? So the first thing that I'm going to do is I'm going to label what I'm trying to find. And it says in the problem to find CF. And so I'm going to be, during the purpose of this video, putting my end result always in this little like squiggle line. That's where I'm trying to get, okay? Now the good thing is that this is the geometric mean. And so I just have to do the ratio that was in that video, okay? And so remember, this is going to come in and it's going to split the hypotenuse into 2 pieces. And so you do 8 over CF equals CF over 50. So that proportion is always going to be the same. So again, it's 8 over CF and then CF over 50, okay? As you do some cross multiplying, okay, you end up with CF squared equal to 400. And lucky for us, when you do the square root of 400, you get a nice pretty number. It's not a decimal, and so we are done. Okay, CF is going to be 20. All right, so number 2 says that we're going to go find WX. And so again, I'm just going to put this little squiggle line here. This is what we're trying to find. Now, 2 things, okay? So number 1, we are doing the geometric mean, okay? And so you want to look in your triangles and all of your pictures. Are you able to do the geometric mean? Sometimes you're going to have to do Pythagorean Theorem to get your answers. And so definitely be looking in the triangles for that, okay? So with this particular problem, I know that I need WX. That is not a part of the geometric mean, which means to get WX, I'm going to have to do Pythagorean Theorem eventually. What I can do is I can go ahead and get this piece by finding the geometric mean. So again, the geometric mean is going to come down. You're going to do 14 over XZ equals XZ over 18. That's how the ratio works every single time, okay? All right, let's go get this cross multiplied. And so I get XZ squared equal to 252. And then I'm going to square root the 252. Now, in my calculator, when I type in the square root of 252, I get a decimal, which means that I'm going to have to go do that simplifying thing that we did earlier with the square root of 80. The problem is that XZ is not what I'm looking for. I'm looking for WX. So I'm going to save myself a little bit of work, and I'm not going to figure out what the square root of 252 is. I don't need it, and I don't care. And I promise there's a method to the madness. There's a reason, okay? You're trying to find out what WX is, and so to get that, we're going to do Pythagorean Theorem. So I'm going to do 14 squared plus this squared equals WX squared. So let's go write that down, okay? So again, 14 squared plus XZ squared, which is the square root of 252, okay, squared, is going to give me whatever WX squared is. The nice thing about this is that when you go to do this piece here, the square and square root cancel out, and the square root of 252 squared is just 252. So that's kind of nice, okay? It kind of worked out really nicely for us. All right, so let's see. When I go add these together, I'm going to get 448. And so I know I need to go do the square root of that. And so, again, when I type that into the calculator, I get a decimal, and so I'm going to have to break this down and simplify it. So 448, excuse me, can be written as 64 times 7, okay? And since I know that 64 times 7 is 448, and I know what the square root of 64 is, which is 8, then my exact answer is 8 root 7, okay? All right, let's go do number 3. Okay, number 3, we're trying to find QS, and that is the geometric mean, so I'm good. I'm just going to do 3 over that equals this over, oh, wait a minute, hold up. We got to find out what SR is, right? Well, if the whole thing is 21 and this piece is 3, this side is going to be 18. So there it is. Let's do it again. So 3 over QS is going to equal QS over 18. Cross multiply, QS squared equals 54. And we have to square root that. I know I'm at the bottom of my page. I apologize for that. So again, when you type in the square root of 54 in your calculator, you're going to get a decimal. So we have to break this up. And so 54 is the same thing as 9 times 6. And we know what the square root of 9 is. We know that that's a 3. And so QS is equal to 3 times the square root of 6. Okay? All right, number 4 is going to be super easy. Number 5 is going to be a little trickier, so let's go through number 5 together, okay? All right, so number 5, we need to find RT. This is where we've got to get when we're done with everything. So again, remember, we're looking for geometric means or Pythagorean theorem, okay? That's the 2 main ideas that we're doing today. And to get RT, I'm going to need a geometric mean. So I'm going to be doing this with RT and then with that. The problem is I don't have any of those values. So I'm going to have to go find some ways to get those values. Okay. I do know that I have a very large right triangle right here that I'm outlining in blue. Okay, so I can do Pythagorean theorem and find out what QR is. So let's go do that. So QR squared, right, is going to be 30 squared minus 27 squared. So in this large triangle, it's my hypotenuse minus the 27 squared. So when I do all of this, I'm going to end up with it being 171. So the length of QR is equal to the square root of 171. Okay, so I'm going to go write that right here so I can label my picture and see what else I have going on. Okay. So this one is a little bit tricky. So I did Pythagorean theorem. I still need to get at least one more number. So either this side or this side. I will tell you that the other thing that you might have to do sometimes are just similar triangles. Okay, and so what I have on this little triangle, okay, what I have labeled is a hypotenuse, right? And what I have labeled on the large triangle is a hypotenuse and a long side. So when I go to set up my proportions, let's go do that. So let's put the hypotenuse and the long side of the big triangle, okay, so 30 and 27, equal to the hypotenuse and the long side of that little triangle. So that's going to be the square root of 121, and the long side of this triangle is going to be QT. Now, lucky for us, okay, for this particular problem, there are decimals involved, which is amazing because who has time to go figure this out, right? I apologize, that should be a 171, not 121, 171. So when I go do that decimal, right? I'm at 353 and divide by 30. And we get 11.77.